Hello, everyone, and welcome to this webinar. I'm going to give everyone a few minutes to be able to come on in. Feel free to introduce yourself in the chat. Mention why you're here, what answers you want, what questions you have, and we'll try to get through everything today. And if not, then we always have our Slack channel, and we'll be able to get questions answered there as well. Okay, we just have a couple more minutes. Going to let people come on in, and then we'll get started. As a reminder, just introduce yourself in the chat. You ask any questions in there ahead of time, and we'll try to look through them as the presentation proceeds. All right, it's 11 o'clock, so we'll get started. This is going to be recorded, just so everyone knows, and so you'll be able to watch it back if you choose to. If you miss any information, but again, you're more than welcome to follow up on the Slack channel, the NATS Slack channel, and we can answer any questions there and clarify anything that you saw in the presentation today. All right. So today's topic is all about migrating from NAT streaming to JetStream, and there's a couple facets to this. One is just ensuring that everyone sort of who is using NAT streaming today gets an understanding of what JetStream is, sort of why it exists, why it is a successor to NAT streaming, and specifically mapping the concepts between the two systems, and sort of some migration considerations for this transition. So quick little short history of how we got here. So NAT streaming was first released in 2016. 2018 brought clustering support, so fault tolerance, high availability, and full-blown clustering, including a RAF consensus. Sort of in parallel, a lot of development work was done on the NAT server itself, the core NAT server, which included, and the 2.0 release was actually quite significant because it introduced a slight change to the actual underlying NATS protocol on the wire, which involved primarily adding support for headers, message headers. But in addition, multi-tenancy was added, the support for superclusters and leaf nodes were added. There was like a whole plethora of things that occurred in that 2.0 release. In March, 2 years later, that's when version 2.2 was released, which actually included JetStream. So JetStream was the new persistent subsystem that is actually built into the NAT server proper, as opposed to being a separate server. Sorry, I'm just checking chat, making sure everyone can hear okay. All right, that's great. And so JetStream is an actual subsystem within the NAT server proper that introduces persistence. Whereas NATS streaming is an external server that can embed the NAT server internally, but it effectively acts as a client that is talking to NATS directly. You can see in April, so a month later after JetStream was released, NAT streaming was marked as deprecated. We knew the team knew, the maintainers knew that going forward, JetStream was architecturally more sound, setting us up for future success. And much more aligned with sort of the core concepts in the NAT server directly. And we are coming up on the 2-year deprecation window ending in June of this year. So that's why we've had a handful of people reach out and say, hey, I'm still running NAT streaming. It still works fine for my use case. But given that no more security fixes and bug fixes are going to be landing after June, maybe it's time to understand how to migrate to JetStream. So we wanted to sort of do hopefully a final pass on this. And again, all questions are welcome subsequently. We want you to have a successful migration. All right, so very simple agenda because we want to really focus on sort of Q&A throughout, but also more dedicated at the end for people who have questions. All right, so let's quickly review some of the sort of observed NAT streaming challenges. Some of these were motivation for JetStream, but also understanding how these things sort of were limiting in certain aspects, certain use cases. So one of the big ones is actually the lack of support for wildcards. So anyone who has used core NATs before, you know that you can publish and subscribe. You can publish to a subject with one or more tokens in it. And then similarly, you can subscribe to a subject with any number of tokens, the exact same number of tokens or the exact same tokens, or you can specify a wildcard like the star that's in the example, or a greater than sign, which says any number of tokens following the previous one. So NAT streaming doesn't support that. So that's kind of a bummer. And we'll look at why in a second. There's no interop between this concept of channels, which is sort of what NAT streaming refers to as subjects, and actual core NAT subjects. So you effectively they were being treated as two separate spaces of subjects. No support for message headers. Message headers didn't exist in NATS at the time NAT streaming was released. However, like I mentioned, in 2.0, that was introduced, but there was no sort of mechanism to get that introduced cleanly in NAT streaming at the time. There's also this notion of client IDs. So anytime you establish a connection to NAT streaming, you have to specify client ID, and that can get kind of cumbersome to manage depending on the scale of your application. There's different reconnection nuances and whatnot that were challenging for people. And you can see, if you look at the documentation, you see there's like these big caveats and these big explanations about how to properly do reconnection, and so on. I'm not going to finish reading all of these, but for those who have been using NAT streaming, you've probably sort of observed this, run into this, understand these limitations. So a lot of the motivation for JetStream, as I mentioned, is to get more aligned with the core NATS concepts. So we want to support wildcards. We want to support multi-tenancy and permissions. We want to be able to take advantage and build new patterns on top of this persistence layer, which is JetStream. We want native support for WebSockets. That's another one that was introduced in previous versions in the core NAT server. So you can actually leverage the NATS WebSocket client that runs in the browser, and you can transparently connect to the NAT server over a WebSocket interface. And then finally, another really nice feature that NAT supports natively, for those who don't know, is actually MQTT 3.1.1 support. That's natively baked in. So you can enable that interface on the server through configuration. And then you can use existing MQTT clients to actually connect to the NAT server directly. And under the hood, MQTT is using actually JetStream transparently. So you don't have to set anything up ahead of time. You just have to have JetStream enabled. You turn on the MQTT interface, and then your clients can actually connect directly. All right, so let's jump into sort of like comparing and contrasting the core things. And I'm leaving lots on the table. This is not an exhaustive JetStream or recent versions of NAT server. It's not an exhaustive talk because that would take a lot of time. I'm just trying to like nail in on some of the core things when people say, how do I migrate, or what's the mental model? How can I go from NAT streaming to JetStream? So very simply, these are sort of the high level areas that I'm going to quick run through and show little code examples. They're written in Go, but they should be fully explanatory, and I'll cover those as we go through them. All right, so let's talk about channels versus streams. So in NAT streaming, you have the notion of a channel, and channels are more or less an implicit type of stream that can get created. You can declare sort of channel configuration as shown up here, and you can specify like limits on specific channels. So I want this channel to only ever have 300 messages in it at any given time, for example. On the publisher side, on the sort of client side, you can say this is SC is my STAN connection, just for reference. And you can simply publish. You can say, I'm publishing to this channel, events.mouse_click, and then you pass it some bytes, whatever your payload is. And that's it. That's simple. That's by design. It's nice. So this is sort of the channel side of things with NAT streaming. And then if we look at JetStream on the right side, you can see some parallels here. One noticeable difference is that with JetStream, you have the full sort of stream consumer management API baked into all of the client libraries, as well as, which I'll show in a little bit later, the CLI. So there's a dedicated CLI that has full JetStream support, which is really convenient. But it's very similar. You can still configure your stream the exact same way. You can still sort of one noticeable difference here, which we'll get to on the consumer side, is that you can create a stream called just named events, but you can define any number of subjects, including wildcards, bound to that stream. So in practice, what this means is that anytime a publisher is publishing to a subject that matches the subjects that are bound to a particular stream, those are going to be received by the stream itself and stored either in memory or on disk, depending on what you configure your stream's persistence to be. But you can see a very kind of clear analog here. And obviously having a runtime API to be able to change stream configurations, define streams on the fly, all that kind of stuff is very convenient. So a couple other things about streams. I mentioned there's a bunch of other configuration that I didn't go into that may be relevant to you. You can, like I said, you can dynamically change most of the options at runtime. So you can change the subjects bound to it. You can change the limits. You can say, I want to constrain to only this number of max messages, or I want to reduce the amount of time that a stream can have messages retained for, things like that. There's also a really nifty feature because streams natively support wildcards. We have that subject level sort of access. And so within a stream, you can actually define one of these retention policies called max messages per subject. And that actually on a per subject basis, you can say, for any given subject, I only want 3 messages, 5 messages, things like that. A couple other really nice things is that streams have deduplication out of the box. By default, it gives you a 2-minute window. You can change that depending on sort of your workload. It does keep these message IDs in memory for that duration of time. So you have to be considerate of like how many messages do you expect in that time window. But essentially, if you supply a message ID, you can be able to get the server will basically say, yep, I already saw this message, and it'll kick it back as it's already been acknowledged, but it won't actually duplicate storing it on the server. A couple other things. This is actually an error. This should have been on the previous line, but that's cool. I'll fix that later. So with optimistic concurrency control, sometimes you have this issue of saying you have 2 publishers and you want to have total ordering on the publishing side. You can actually specify the expected sequence number of the stream at publish time. And so you can and this can be at a stream level or a per subject level on a stream. And you can allow for concurrent publishes, but they actually can get serialized properly. And then the final couple other things, again, depending on your use case, there's mirroring of streams, there's sourcing of streams, and these are all other topics that if people are curious, you can ask questions, and I'm happy to get into them. Roll-ups and this nice pattern republishing, which allows you to essentially publish to a stream, and then the stream internally on the NATS server is actually rebroadcasting that message out to a core NATS subject, providing a very sort of lightweight fan out republish from any write that comes into a stream. All right, moving on to just checking questions. Any questions coming in? Chat. And there's a handful of other Canadians in here to be able to answer questions. So feel free, like I said. All right, cool. So we have subscriptions and consumers. So a subscription is sort of a multifaceted term in this context, and I'll explain why in a second. So a subscription on the NAT streaming side is what you would expect. You can subscribe to a given channel. Again, it does not support wildcards. So you can't say, even though we might want events.star to get all types of events, you can't do that in NAT streaming. So subscriptions do not support wildcards, as a reminder. So you'd have to, that's going to influence your channel naming convention essentially, but you would essentially have to create multiple subscriptions per per channel that you would want to consume from. And another notable thing is that, like I said, the NATS streaming sort of API is not the same as the NATS, the core NATS API. And so this is a standalone separate library in Go, which is the stand library, and it has its own message type. It has its own internal representation as a protocol buffer message. So it's just different from sort of the original core NATS API. So again, it's a little different. So if you want to leverage basically the benefits of core NATS pub sub along with NATS streaming, it was a little awkward to use in practice. So here's a couple of quick examples of creating an ephemeral subscription. On the NATS streaming side, you don't supply a durable name. So the second that you close or unsubscribe that subscription, it's going to go away. Pretty obviously, if you supply a durable name, it creates a durable consumer, and you can specify essentially the starting point in the channel for which you want to start consuming messages. So deliver all available will say, I want to go back to the first message that exists in that channel and replay everything up to the current message. And then finally, you have this notion of a queue subscription, which effectively defines this queue group name. And this is analogous to, again, the core NATS queue subscribe as well. It's the same basic idea, same API. On the JetStream side, on the right-hand side, so a NATS streaming subscription is analogous to a push consumer, and I'll just talk about that in a minute. There's two types of consumers in JetStream, and your mental model of a consumer can be, this is a view of state over a stream. So you have a stream, let's say it has 100 messages in it. You create a consumer. Let's say you want to start from the very beginning of that stream. As messages are being pulled through that consumer, and the consumer is delivering it to message handlers, the subscriptions, analogous to NATS subscribers, core NATS subscribers. Every time a message is handled, it's acknowledged. Every time that acknowledgement comes back, or there's other acknowledgement types that I'll mention in a second, but the simple path is that if I'm pulling down a message, I'm acking it, that acknowledgement is actually going back to the consumer, and the consumer has local state on the server to say, all right, great, I already delivered that message. It was acknowledged. I'm obviously not going to re-deliver that again. So NATS streaming is doing that internally. It's keeping track of this sort of consumption state. Like, have I delivered this message yet? Has it been acknowledged yet? But with JetStream, this notion of the consumer has been made sort of first class, that you can create these explicitly, you can manage them explicitly, you can change the configuration at runtime explicitly, similar to Stream. So we wanted to sort of like create these stream and consumer primitives as first-class citizens now in JetStream. So it makes it a little bit more explicit and sort of obvious what you're doing. So with this JetStream API, we have an analogous sort of, you can think of it as like a convenience API in the client libraries, where you can say js.subscribe. And now in this case, wildcards are supported, as I mentioned before, and it's using a standard NATS message handler, including the native message type that exists in the core NATS library as well, or core NATS, core NATS library, sure, go with that. So you can see that these are analogous, right? This sc.subscribe, js.subscribe. The difference, however, is that this subscribe is sort of implicitly creating a consumer under the hood. The library itself is doing that. So every client library is doing that on your behalf. And in this case, it is making an ephemeral consumer because we're not supplying any kind of durable name. But the syntax is actually very similar, where you supply a durable name if as an option to the subscribe function, if you want to use this variation of syntax and like sort of convenience for creating your consumers. You're welcome to do that. And I'm pretty sure all of the options that that exist for consumer options can be passed as options to your subscribe call in this case. The second little block here is simply showing how do you explicitly create a consumer. You specify the stream you're binding this or you're creating this consumer for, and then you specify consumer configuration. In this case, I'm just showcasing that this is a way to create a durable pool consumer, which is a different consumer type than what NAT streaming provides. NAT streaming is much more of a kind of push-based model, whereas JetStream supports push-based as well as pull-based. So a pull-based model is allowing you to explicitly fetch a batch of messages at a time. And in this case, if there happens to be 10 messages available to be fetched, it'll fetch all 10. If there isn't, it's not going to wait, and it'll just fetch the most recent next message. So there's different sort of behaviors that you can achieve with this depending on your use case. And there's other really interesting things with these consumer types, but we'll talk about that another time. All right. Oops, sorry. All right. So quick review of consumers. You can bind them explicitly to a stream with their own configuration. You have more sort of options. There's a plethora of options with consumers, including a subject filter, which is interesting. I did show that in the last slide. I just didn't mention it. So because a stream supports any number of subjects that are bound to it and any number of wildcards bound to it, you can actually say, I want to create a consumer that has a filter applied to it, and I'm only going to be receiving through my subscribers bound to that consumer. I'm only going to be receiving messages that are matching this subject filter that I specify. So in other words, you're effectively doing server-side filtering of a stream for a given consumer. And every consumer can have its own, it can consume everything. It can consume any number of different filters. And coming up in our next release, next minor release 2.10 in the future, we're actually going to be specifying multiple subject filters for any given consumer, which has been a pretty highly requested feature. And the one final note on the acknowledgements, I mentioned that before, you have a lot more control. So when you receive a message, you can say message.ack, which is the same approach that you'd use for NAT streaming if you did manual ACK mode. What's nifty about consumers for JetStream is that you can actually say NAC, a negative acknowledgement, to say, no, I reject this for some reason. And then that basically signals the consumer to say, okay, this was negatively ACKed. I'm going to actually go redeliver it. And there's different redelivery configuration options as well. You can do NAC and wait. So you can say NAC and wait for this duration of time before the server actually goes and redelivers it. You can signal an in progress, and an in progress is useful when you have for every message, the default ACK wait time is 30 seconds, if I recall properly. That's also configurable on a consumer basis. But let's say that you're processing a message and you're like, well, I'm not going to get done in time. I'm not going to get done in 30 seconds. I can signal to the server, hey, I'm in progress. And it actually resets the timer for that individual message on the server, so it doesn't attempt to redeliver it after that 30-second window has elapsed. So that's another nice feature depending on your work, again, your workload and sort of how long your message processing actually is. And then finally, a terminate acknowledgement, which basically says, negative acknowledge this, and I don't want it to be redelivered because there's something, maybe the payload is corrupt or something. All right, so I mentioned those sort of like one-to-one correlations between streams, channels, and consumers and subscribers. There's a broader overarching vision just to kind of call out here, which is with this news persistence layer, with streams, we have now the ability and to be able to create additional patterns on top. So two of which that some people may have heard of or used is the key value API that is built on top of the stream stream layer. So it's not a new persistence thing. It's literally built on the same persistence foundation of a stream. And then the object store API, which is still experimental at this point, but this is going to allow you to effectively stream large objects, large files of sorts, large blobs that would exceed a typical NATS message size, which by default is 1 megabyte. That's configurable, but that's the default size. So if you have a 100 gig file, the API that is exposed for object store would allow you to say, hey, upload this thing or send this over on a stream. Under the hood, again, it's a stream, but it transparently chunks up your object into smaller messages that are totally ordered. And for the client uploading it or the client downloading it, everything is kind of transparently deconstructed and reconstructed. And it takes advantage of all the benefits of the streams and the fact that you can create mirrors of these things in different geographies, different regions across the globe. So it sort of inherits all of those really nice properties that is the foundation of what JetStream enables. And so at the end of the day, you have NATS with JetStream built in. You have now the spectrum of different patterns, different different patterns and different delivery guarantees that you can choose between your services, between your workloads, whatever it is that you're building. All right, quick check on comments. Let's see anything here. Is there any danger in creating a single stream with subject star? I asked because, right. So that's a good question. So because NATS, because JetStream supports NATS subjects directly, natively, that could cause a problem. So you could say, all right, I want to stream that says the subject is a wildcard star or even greater than. That would then mean anything that publishes that would match that particular subject, which would be anything, either one token of anything or a greater than, which is any number of tokens. So everything. Yeah, that would be a problem. So in practice, what you typically do is create a stream that has a single token prefix. Typically the stream name is like convention. So you could say again, like devices.star as the subject, right? And maybe my stream is like device state, right? I'm keeping track of all my devices. This is like an IoT thing or an edge device thing. And I'm keeping track of all the state of all my devices as an event stream. And you can say events.star, and then that star, when you publish, could be events.some UUID to match your device. So you always sort of want to have a prefix, and you want to think about sort of your subject hierarchy that is going to be then scoped to a particular stream. And so that's generally how you would tackle that problem. Does JetStream file store persistence preserve message delivery guarantees through NATS server restart? Yes, it does. Yep. So the way that, and interestingly enough, if you have a cluster of servers, if you have a 3-node cluster, and behind the scenes, clustering in JetStream also relies on the Raft protocol. So if you create, let's say, a stream with 3 replicas, you're going to have the leader election, you're going to have a primary, and then you have the 2 other replicas on the other nodes. And so you can obviously tolerate a single node going offline, and you can still accept writes. And if 2 nodes go offline, then you're stuck because that's what the Raft protocol allows. You can go up to 5 nodes if you really need to. So there's all a bunch of different sort of topology configurations that you can consider depending on what the stream is intended for. We have users and customers that are creating streams that are, we refer to them as like R3, so like 3 replicas, or R5 streams. You can have in-memory streams that are R3 that still can technically tolerate a good rolling restart of all 3 servers if you're careful, even if it's in memory, because the state basically just moves around. So yeah, you have a lot of options, which is again an advantage over NAT streaming, where with a channel you didn't really have that flexibility. You couldn't say this is an R1 stream that's in memory that's going to be super fast but still provide some persistence. some decoupling of time specifically, or you can have your R3 streams and so on. So that's there's a lot of options there. Does consumer subject filtering happening on the server or the client? It happens on the server. So this is a big advantage over a lot of other messaging systems, which and streaming systems that don't really give you that option. So if you specify your subject filter, it before the consumer on the server actually sends the message, it's going to obviously skip, ignore all of the messages that don't match that filter, and then it's only going to send. So you're saving on bandwidth. It's going to be faster in general because you're not needing to chug through everything that you don't need, and you're not needing to drop everything on the floor on the client side. Great questions. All right. So here are some topics. Again, these are like not super in depth. Some of them are actually quite simple, but it's more calling out some basic considerations to get started. And some of these, again, depending on your use case, depending on the system you're migrating, you might need to get much more in the weeds and in depth with sort of nuanced decisions. But given that NAT streaming, sort of what it currently supports in many of these areas or none of these areas, this is sort of like all new stuff that you might want to explore that might improve your architecture or your system as a whole. So first thing is, how do I even configure JetStream? Well, it's quite simple. Very simple. Just like NAT streaming was, there's a handful of small config options. You can get started if you just need to spin up a sort of temporary JetStream enabled server. There's a nice little CLI option right there, --JS. But in the server configuration for more of a production deployment, you can specify obviously your storage directory, a maximum amount of memory persistence, a maximum number of file storage persistence. And then you even have the option, obviously not required, but you have the option to do encryption at rest as well. So there's a couple ciphers that you can choose from, and then you can pass in your encryption key as an environment variable is typically what is recommended. So very simple to just kind of enable JetStream. It's very, very simple like that. Deployment considerations. So this is, in my opinion, it's actually simpler because we're removing a component. So again, depending on how you chose to deploy NAT streaming previously, you had the option of standing up a NAT server, a NATS cluster itself, and then having NATS streaming servers connect to that cluster. That was one way that you could set things up. And if that's still the case, then that's sort of even more convenient because you can just remove the NAT streaming server component. And as long as your NATS cluster is on a recent version that obviously has JetStream enabled, you basically just have your client applications connect to the cluster directly, and you can start managing assets, assuming you've configured it with JetStream enabled. So you could potentially be removing a component that you'd have to manage and deploy. But if you're using the NATS streaming with embedded mode, which effectively embeds the NAT server directly into the NAT streaming process, and then you had those clustered together, in that case, you would have to sort of transition to a vanilla NAT server cluster, and you'd configure the routes to be able to have all of the nodes talk to one another. So very straightforward. There's documentation on setting that up, but yeah, if you have any questions, feel free to ask. And then what this also enables, that is supported by JetStream in various ways, is this notion of superclusters. If you need to create multiple clusters across different regions that need to connect to one another, you can create leaf nodes, which is a whole other topic. There's a Kubernetes Helm chart available as well that has JetStream enabled, and there's really good integration with sort of the classic Prometheus Grafana monitoring stack. But yeah, if you have any questions on deployment, feel free to ask about that. But it's pretty straightforward. Something brand new that didn't exist in NAT streaming is this notion of multi-tenancy, which is again baked right into NAT server. even if you're using still a standard username and password in your server configuration for NATS, internally, it actually is creating this global account. It's like this implicit account that exists under the hood that is implicit. You don't have to worry about it. But if you want to leverage accounts, you can explicitly create them in your server configuration. And then there's a sort of a more advanced, but for certain use cases at scale where you need to manage multiple, like many accounts, there's this decentralized authentication authorization model that NATS supports today, which again is a whole other topic, but there's a lot of really good content. And I'm going to go over some resources at the end that you can look to learn about those. So, but in a nutshell, what does accounts give us? Accounts give us complete and full subject level isolation. What that means is that if I am a client application and I have user credentials, let's say for user AA right here under account A, and then I have a separate client application with user B under account B, those two client applications by default will never see any messages, even if they're publishing and subscribing to the exact same subjects. So it gives complete full isolation. So you can have one NATS deployment, one NATS cluster, supercluster, what have you, and you have accounts that are all effectively just using this cluster, and they're not even aware of any other accounts that exist. And you're never going to step on each other's toes, which is really nice. So it's true sort of subject level multi-tenancy. In addition, accounts, as you can kind of see here, every account can have its own JetStream configuration in the sense that you can enforce certain limits at the account level. So for users or applications that customers create that they want to map a NATS account to essentially one of their customers, and they want to control, let's say, the number of resources that they want their customer to be able to use, you can explicitly set JetStream limits at this level. And then if you do have a desire to create to allow for cross account sharing, we refer to those as exports and imports. You're exporting a service or a stream that another account could import. That is also supported as well. So that's typical in practice. Those are typically used for sort of operational type things where you might need to, as an operational account, need to be able to expose or allow for sort of your edge accounts, your other accounts to be able to communicate briefly back to sort of this hub. So it is supported for a handful of use cases. All right, we have a couple more slides, and then I promise we'll get to questions, more questions. Authentication and authorization. So this is another area where the NAT streaming side was fairly basic. You didn't have too many options there. So NAT server, again, as of 2.0, which has been a while ago now, and obviously since then we're at 2.9, the 2.9 series of releases. Today, the NAT server supports your basic auth, username, password, tokens, N keys, bcrypted tokens, TLS certificates that you can actually map to users. And then I mentioned this decentralized auth model, which is, again, a whole other topic in and of itself. So the authorization piece, which is also sort of interesting and useful for applications, is the ability to set permissions, subject or publish and subscribe permissions on a per user basis. So you can kind of see in this example that I have, under the single account, I have two users, admin and test, and the admin user can obviously publish and subscribe to everything. That's what that wildcard, that greater than sign is. But then the test user can only publish to events.star, or and they can only subscribe to this inbox thing, which is typically for replies back. So if, let's say, if there's that event stream, as I mentioned before, this test user could be publishing events that are being received by that stream, and the stream is actually going to be sending back an acknowledgement to an inbox that, and this happens all transparently by the client libraries, but this is what the server does is it sends back an acknowledgement to the client to say, this is your sequence ID for this event that was just published and stored in the stream. So you want to be able to allow that sort of request reply interaction between a client and a stream in this case. But point is that you can lock down these permissions quite in a quite nice way, again, depending on what your needs are. All right. Another really good call out is the command line, the NATS CLI, as well as the client libraries. So the client libraries, all the official client libraries support JetStream that are sort of maintained by the core NATS maintainers. That's on the website under the nats.io/download. You can see sort of the official client libraries that are maintained. And then there's, of course, a plethora of awesome community created clients as well, some of which have JetStream support, but sort of support might vary depending on how well maintained those libraries are. But all of the sort of official ones have full JetStream support. It's really worth calling out. This is probably a little small to see, but this NATS CLI, I mentioned that you have full control over managing streams and consumers and all these assets. So the NATS CLI is super convenient because it has all of these nice command line, these subcommands that allows you to list streams, edit streams, temporarily view messages in a stream. So it's a really great tool to sort of play around with, get started with. And it also has this benchmarking capability that supports JetStream. So you can say, I have my cluster set up. I want to basically test the performance of writing data to a stream that exists on this cluster with 3 replicas. And you maybe provision certain VMs with certain qualities of disk and things like that. And you can basically see what's my throughput, what's my latency, depending on the network that you're on. So that's all just baked into the CLI, and it's awesome, and people use it all the time. And so this is another really good first class tool for interacting with JetStream. And finally, but certainly one of the most interested topics is how do I actually migrate the data? So I think it's straightforward to, and sort of what I was alluding to before, the concepts and the APIs going from a NATS streaming client library, for example, to a JetStream client library, which is the official NATS client libraries. It's not a separate thing. The APIs are all baked into the official client libraries. Those are pretty straightforward. Like, you're going to have to update your application code. That's just the reality of things, because it's a completely different system under the hood. But the main question is like, well, I have channels, I have my consumers, my subscription state in NATS streaming. How do I actually convert this stuff over? Which is obviously a valid question, because you're just not going to throw data away. Fortunately, it's actually not bad at all. And so much so that I unfortunately did not get to finish it yet, but I will be sending around a NATS by example possibly by tomorrow. And I intend to potentially create a standalone little CLI to assist in migration between a NATS streaming setup and JetStream. But the NATS by example is going to be really focused on walking through effectively what I'm listing out here. This is like sort of the pseudo algorithm of how you would approach this. You have to create streams per channel with an analogous configuration. Those fairly map one-to-one pretty well. You have to republish all the messages from the channel to those new streams. Importantly, and this was what can catch people up, is you need to map the sequence number from the message in a channel to the new sequence number that gets created in the stream. And so you're just mapping from one integer to another integer effectively. And the nice thing with JetStream using native NATS messages, it has header support. And so you can even bake in the NAT streaming sequence number as metadata as part of a header field in the new message that you publish, just for sort of reference if you need that. The second half of this is to say, I need to enumerate all my durable subscriptions on the NAT streaming side, capture the last sequence number that basically I've paused at. You create an equivalent consumer in JetStream for all of those subscriptions. And then you explicitly set that start sequence, taking into account the mapping from the old channel sequence to the new stream sequence. And so what you're doing is you're effectively carrying over the consumer state to say, all right, now when I connect my application and I resume for that consumer, it's going to resume on the equivalent stream at the starting point that is equivalent to what you had in that streaming. So that's the idea. And again, this is like straightforward. There might be other use cases that I'm unaware of saying, all right, well, this isn't sufficient for my needs for my sort of data migration. But again, if you have questions, if you have thoughts, if you have concerns about this, feel free to ask questions, or we can always follow up on the NATS Slack. But like I said, I'm going to be creating an example for this just to kind of show and walk through it. And then you can take that and implement it in your own context with your own client code and things like that. Or if a standalone CLI to just do this sort of like one-shot migration of data, that might be sufficient for some people as well. All right, so now we're into Q&A. If people have more questions, we have about, I did pretty good on time. Just under 15 minutes. I'll switch over to just this, leave it on this slide. So if people aren't aware of some of these resources, the Rethink series, our series of video tutorials that are quite good, introducing a lot of the JetStream concepts and some of the sort of advanced topology topics and permissions and things like that. But it's a really, really great resource. I mentioned NATS by example. There's a whole bunch of JetStream examples in there to learn the different types of stream types and the consumer types. And it hopefully, again, is easy to follow. That's the intention. So they should be fairly well explained. So there's that. Of course, the NATS documentation, and then the newsletter. And I put that in there simply because I am the curator of that newsletter, but I try to always kind of keep the news, keep the information up to date. So any new examples that get published, any new significant documentation edits that get published, of course, any new videos that get published, as well as a bunch of community resources out there, blog posts, things like that, and any server releases or client releases all get aggregated in this newsletter that comes out every week. So it's a nice resource to just kind of keep a pulse on the NATS ecosystem. So if you haven't signed up for that yet, you can go to that link and there's a box to be able to put your email address in. All right. Let's see if we have any more questions. It would help me if I can find anything and see anything. So hopefully, yeah, I mean, if there's, give folks a couple minutes to think of any questions, if you have any. Hopefully this was helpful. And again, this will be uploaded to our Synadia YouTube channel for reference if you want to look at it again. And again, if you go to the NATS Slack channel, it's slack.nats.io is like the short URL to access the NATS Slack. Hop in there, and the whole team is more than happy to answer any questions that you have as well. Simon, do you have to declare a stream before publishing to JetStream? Yes, you do. Yes. So that's one subtle nuance. Whereas I know with NAT streaming, you can say like sc.publish and implicitly it'll create a channel. And I think the reason for that primarily is because you have you have both access to the core NATS standard publish subscribe without streams and consumers, and you have access to the sort of persistent versions of those using streams and consumers. So whereas NAT streaming, you only have access to channels. You don't have access for sort of these ephemeral publish and subscribe, request reply type of interactions that you have with core NATs. So you have to be explicit to say this subject that I'm publishing to is in fact mapped or bounded to a stream that I've already declared. Good question. Will NAT support SQL? Oh, this is always a fun one. So it depends. So you mentioned KSQL. Okay, so there's nothing on the roadmap right now for supporting KSQL. However, there's been a lot of discussion of materialization. So I actually did. We had a little virtual conference last fall called Rethink Con. That's also on our YouTube channel. But I demoed a short thing to showcase how you can have this process that is effectively, as you call out, materializing tables in a SQLite database in this particular case from streams. And you had this ability to create these append-only tables that were more like event-based, or you could declare a table that is essentially key-based, where if given some identifier, such as a subject ID, or some property within a JSON payload that you've defined, it actually would replace an existing record in that table. So it sort of acts as a sort of analogous to a streaming table or a K table, if you're thinking in the Kafka space. So that's one demo that a lot of people, and again, the use case for that was really, and the choice of SQLite in particular was to showcase how could I deploy a leaf node or a small little relational database at an edge location in an edge device or something that is able to source data from streams, materialize it locally, and then you can still have your client application interact with a proper and native database. Whereas with KSQL DB, it's its own thing, it's its own database. So it's sort of materializing sourcing data into KSQL DB, but it's its own database. It's not Postgres, it's not SQLite, it's its own thing. So it's one of those sort of decision points where what do users actually want? Do they simply want really fast like near real-time materialization into tables that you can natively just kind of query through your own SQL tools, BI tools, SQL clients, things like that? Or do you want, which in my opinion, I think the sort of novel thing with KSQL DB is really the streaming queries, which is like it's a whole other type of thing. Certain use cases prefer that, and sometimes materializing a table and re-executing a query every so often might also be sufficient. So that's where there's a whole spectrum of potential things you can do with SQL plus streams. So again, if people have concrete use cases and they're like, how could I solve that problem? Do I have to achieve a certain latency between landing in a stream and being able to query it? That's typically sort of a very key thing to understand. More than happy to again discuss over Slack, because it's a very hot topic. A lot of people have been talking about it, and we are absolutely interested in exploring that much more. We just don't have anything concrete yet on the roadmap. What are the options for backup? Right, good question. So there is a native backup and restore command actually baked into the CLI. There's also a NATS sort of subject NATS API behind the scenes that you can actually interact over strict request reply type of interactions. But there is a native NATS backup and restore for any given account. And it will snapshot all of your streams and all your consumer state. And then you can just as easily restore everything back into a new NATS cluster or an existing one if there's a disaster. So that there's much more first-class support for that. And then the other sort of nuance to that, because this is, again, another really common question, which is sort of backup and restore is obviously going to be not the slowest per se, but it's like you're snapshotting it in time. So you're always going to have that window of, let's say my entire cluster goes down, all my disks get corrupt, the worst possible case scenario kind of thing, a meteor hits. Yeah, you can restore then, but in practice, what typically happens is that because you have that freedom and flexibility of creating or defining your streams and consumers, interestingly enough, the consumer replicas actually inherit from the stream, but you can say, I want an R3 stream, I want an R5 stream. If you properly set up your cluster where you have, let's say, a 3-node cluster, each server is in a single availability zone, all of which are in a single region, that can tolerate a lot of failure. And so even if you lose node, disk gets corrupted, you still have 2 copies there. There's another sort of extension to that use case, which is this notion of mirrors, which I mentioned, but it didn't get into. A mirror allows you the ability to basically create a bit for bit copy of a stream in one location, typically in one cluster, and replicate it asynchronously over to another cluster. And so again, you have that very small window of asynchrony, but it's going to be way more up to date than a backup restore. So you sort of have these like tiers of replication and sort of redundancy that you can bake into your system, depending on sort of how volatile you expect your environment to be. Because not everyone is obviously running in cloud providers. People have their own co-located data centers and things like that. Some obviously with edge locations and things like that, you have to be more cognizant of an edge device. Someone could take a hammer to it or something, right? So you have to be cognizant of that. But so it really depends. But there's definitely a bunch of different options that you can use to set up depending on your needs. All right, going down to the list, we got 2 minutes left. Final 2 questions, and then again, feel free to carry any of these over to the Slack. Can you talk quickly about cloud options for hosting NATS? Sure. Yeah. So Synadia does offer a hosted SaaS offering called NGS. It may or may not be sufficient for your use case, for your needs, but it's effectively a globally deployed NATS cluster across all 3 major cloud providers across, I think it's 13 regions across the globe. So what's kind of cool about that is not everyone has global problems, not everyone has global use cases, but depending on where your users are, where your clients are, it makes it super easy to create applications and extend this cluster with leaf nodes and other things without needing to necessarily set up a full-blown cluster yourself. And you can kind of just get started connecting to it. You get an account, you can mint all your users, things like that. And it's pretty plug and play to get started with. And there's a free tier, even if you just want to try it out. So you can sign up for free, and you have a sort of limited set of JetStream assets that you can create. But it's pretty straightforward to get accustomed to. I mentioned the Kubernetes Helm chart. So if you have any Kubernetes deployment on any cloud provider or self-hosted, you can deploy there. That's really straightforward. A lot of customers use that. And we are just in the process of introducing an AWS Marketplace offering that is not yet landed, but going to be, I think, in this first quarter of the year. So that should make it a little bit easier for procurement through organizations where they're like, I have an AWS environment, I want to go to the marketplace, I want to like spin up my server kind of thing, like nice and easy. But in general, the NAT server is so simple to run. You can just as easily spin up a handful of VMs turn them on, set up the configuration, connect them, and that's it. So there's not a lot of like ceremony with running a NATS cluster, but you have different options. All right, final question. When is the object store expected to be GA? I believe the roadmap is indicating mid of this year, but don't quote me on that. If you go to nats.io/about, I believe the roadmap is at the bottom of the page. You can check that out. But again, this is another one that, so the key value, when that was introduced, that took off. Everyone started adopting that. So a lot of the effort of making that mature went into the key value API, and object store is going to follow not long after. All right, just as a reminder, we're at time, but this is recorded. So once I publish it up to our YouTube channel, I'll send out a follow-up email to folks who attended, and I'll post it around. It's able to be watched by whomever, of course. So I'll share that, and then I'll share a follow-up with the NATS by example for the data migration bit as soon as I can. All right. Thank you so much, everyone. Have a great rest of your day.